Hello everyone and welcome to the lecture on AWS X Ray. So this lecture will contain all these topics. What is AWS X Ray? How X Ray works? X Ray's interactions with instrumented applications. AWS services integrated with X Ray. Concepts, and those concepts will be segment, subsegments, service graph, traces and sampling. So what is AWS X Ray? AWS X Ray helps developers analyze and debug production applications, especially distributed applications, enabling them to maintain optimal performance. X Ray is particularly useful for applications built using a microservices architecture, which can be complex to manage and troubleshoot. With X Ray, developers can gain insights into how their application and its underlying services are performing, making it easier to identify areas for improvement. X Ray assists in identifying and troubleshooting the root cause of performance issues and errors, reducing the time and effort required to resolve problems. The service provides an end-to-end view of requests as they travel through the application, giving developers a comprehensive understanding of the application's behavior. X Ray generates a visual map of the application's underlying components, making it easier to understand the relationships between services and identify potential bottlenecks. Developers can use X Ray to analyze applications both in development and production environments, from simple 3-tier applications to complex microservices applications consisting of thousands of services, ensuring continuous improvement through the application lifecycle. How X Ray works? To use X Ray, you must first instrument your application so that X Ray can track how your application handles a request. Adding instrumentation lets X Ray send trace data and metadata for incoming and outbound requests and other events within your application. X Ray assigns a trace ID to any request that your instrumented application receives. This trace ID is used to track the request throughout the application workflow. Throughout the application workflow. If your application interacts with another component, X Ray creates a segment. This segment is associated with the original trace ID and tracks the quality of the interaction with that component. X Ray tracks the trace ID and segments throughout your entire application workflow. This allows for comprehensive monitoring and analysis of application's performance. With X Ray, you can analyze the entire workflow or isolate a piece for detailed analysis. This flexibility enables developers to identify and troubleshoot issues effectively. X Ray interacts with service nodes. You use trace ID and segments for tracking. So X Ray uses a trace ID and segments to track individual interactions between your application and service nodes or components. An AWS agent collects the trace ID and associated segments and then passes them to an SDK or API trace framework for further processing. X Ray also tracks interactions with any AWS services that integrate with X Ray, providing a comprehensive view of the application's behavior. The agent sends data to a console GUI where you can view the information about your traces, segments, subsegments and how these components interact, thus enabling effective monitoring and troubleshooting. Now let's see how X Ray's interactions with instrumented applications. When your instrumented applications receive a request, X Ray starts tracking the request journey through your application. After your application serves the request, X Ray SDK sends trace data, including the trace ID and segments, to an AWS collector or agent. AWS distro for open telemetry, collector, Amazon CloudWatch agent or X Ray daemon, depending on your requirements and preferences. So there are 3 options: collector, CloudWatch agent or X Ray daemon. The chosen agent sends the collected trace data to a tracing framework, which consists of either an AWS API or an AWS SDK built on top of an API. This framework enables interaction with other AWS services. The tracing framework can optionally interact with other AWS services, HTTP servers, methods and queries. The SDK or API keeps track of trace data during these interactions. Some AWS services such as Amazon EC2, Amazon SNS and API Gateway integrate with X Ray. They can add tracing headers to incoming requests, send trace data to X Ray, or run an agent to collect trace data. You can view data about your traces, segments and subsegments in the X Ray's console's graphical user interface. X Ray generates a detailed trace map using trace data from AWS services that your application interacts with. The trace map shows the client, your front-end service and back-end service that your front-end service calls in a single request, helping you identify performance issues. X Ray also generates a service map that provides an overall view of how your application interacts with your service nodes. Edges in the service map connect the service nodes, showing communication frequency and latency between them. Okay, let's see AWS services that are integrated with X Ray. First one is AWS Distro for Open Telemetry, ADOT. With ADOT, engineers can instrument their application once and send correlated metrics and traces to multiple AWS monitoring solutions, including Amazon CloudWatch, AWS X Ray, Amazon OpenSearch Service, and Amazon Managed Service for Prometheus. Then AWS Lambda, active and passive instrumentation of incoming calls on all runtimes. AWS Lambda adds two nodes to your service trace map, one for AWS Lambda service and one for the function. When you enable instrumentation, AWS Lambda also runs the X Ray daemon on Java and Node.js runtimes for use with the X Ray SDK. Then Amazon API Gateway, active and passive instrumentation. API Gateway uses sampling rules to determine which request to record and adds a node for the gateway stage to your service map. Next one is Elastic Beanstalk. Elastic Beanstalk includes the X Ray daemon on the following platforms: Java Standard Edition 2.3.0 and later, Tomcat 2.4 and later, Node.js 3.2.0 and later, and Windows Server. Then Elastic Load Balancing, request tracing on application load balancers. The application load balancer adds the trace ID to the request header before sending it to a target group. Next one is Amazon Event Bridge, passive instrumentation. So if a service that publishes events to Event Bridge is instrumented with X Ray SDK, event targets will receive the tracing header and can continue to propagate the original trace ID. Next is Amazon Simple Notification Service. This is also passive instrumentation. So if an Amazon SNS publisher traces its client with X Ray SDK, subscribers can retrieve the tracing header and continue to propagate the original trace from the publisher with the same trace ID. And lastly, Amazon Simple Queue Service, again passive instrumentation. If a service traces request by using the X Ray SDK, Amazon SQS can send the tracing header and continue to propagate the original trace from the sender to the consumer with a consistent trace ID. Okay, now we'll see all some of the concepts, important concepts related to X Ray, which are segment, subsegments, service graph, traces, and sampling. So first is segments. The compute resources running your application logic send data about their work as segments. A segment provides the resource name, details about the request, and details about the work done. For example, when an HTTP request reaches your application, it can record the following data about the host, hostname, alias or IP address, the request, which can be HTTP method, client address, path, user browser agent, the response, HTTP status response, and the content, the work done, which are start and end times and subsegments, issues that might have occurred like errors, faults, and exceptions, including automatic capture of exception stacks. Next, let's see what is subsegments. So subsegments break down segments into subsegments for more granular analysis and to instrument specific code functions. Subsegments provide precise timing and additional information about calls to AWS services, external APIs or databases. X-Ray uses subsegments to create inferred segments and downstream nodes for services that don't send their own segments like DynamoDB. Subsegments ensure the trace map includes all relevant services, even if they don't support tracing or are external to AWS. Subsegments represent the application view as a client, replace inferred segments with actual ones, and update the service graph with the accurate data using the subsegment for edges between nodes. Okay, next concept is service graph. X-Ray uses the data sent by your application to generate a comprehensive service graph. Each AWS resource that sends data to X-Ray appears as a service node in the graph, providing a clear overview of your application's components. Edges in the graph connect services that work together to serve requests, connecting clients to your applications and your application to downstream services and resource it uses. The service graph is represented as a JSON document containing detailed information about the services and resources that make up your application. The X-Ray console uses the service graph to generate a visual representation known as a service map, and this makes it easier to understand your application structure and interactions. In a distributed application, X-Ray combines nodes from all services that process requests with the same trace ID into a single comprehensive service graph. The first service that the request interacts with adds a tracing header, which is then propagated between the front end and the service it calls, ensuring consistent tracing throughout the application. Next, I will talk about traces. A trace is a collection of all the segments generated by a single request as it moves through your application. Each trace is assigned a unique trace ID, which is used to track the path of the request as it travels through your application components. Most often, a trace begins with an HTTP GET or POST request that enters your application. The incoming request typically interacts with a load balancer and then your application code, where it is processed and generates further actions. As the request is processed, it may generate downstream calls to other AWS services or external web APIs, extending the trace. The first AWS service that supports X-Ray tracing and interacts with the request adds a trace ID header to the request. The trace ID is then propagated downstream to all the other services and components involved in handling the request. By propagating the trace ID, X-Ray can track various data points such as latency, disposition, and other request metadata across the entire path of the request. Okay, last concept is sampling. The X-Ray XDK applies a sampling algorithm to ensure efficient tracing and provides a representative sample of the request that your application serves. This algorithm determines which request gets traced. By default, X-Ray SDK records the first request received at the beginning of each second and 5% of any additional request. This default setting helps balance tracing efficiency and representativeness. To avoid incurring service charges when you are getting started with X-Ray, the default sampling rate is set conservatively, and this ensures that you don't accidentally trace too many requests and incur unexpected cost or the charges. You can configure X-Ray to change the default sampling rate and set up additional rules that apply sampling based on specific properties of the service or request. This allows you to customize the sampling behavior to suit your application's needs. In some cases, you might want to disable sampling entirely and trace all requests for calls that modify state or handle users or transactions. This ensures that you have a complete record of critical operations and can accurately track and debug any issues related to state changes. For high volume read-only calls such as background polling, health checks, or connection maintenance, you can reduce the sampling rate to minimize the overhead of tracing these frequent but less critical operations. This helps optimize the performance and cost effectiveness of your tracing setup. And that's all. Thanks for watching.